Okay, this is from the free response questions from 2015, number 1, about the drain pipe. So get that in front of you. Okay, so we have water going into a drain pipe. So R of T is the water going in. And then we have D of T, which is the water going out. And we're talking about the interval from 0 to 8. Okay, so part A. How much water went into the pipe? So going in is R of T. So we're going to have the integral from 0 to 8 of R of T dt. This is a calculator question, so you're going to pop it into your calculator. And you're going to get 76.570 cubic feet, or feet cubed. Okay, so the point value for that is 1 point for this and 1 point for that. Okay, I'm going to erase, go on to part B. So that was pretty easy, that first part. Okay, go back to my beautiful green color. Okay, so part B. So is the water increasing or decreasing at T equals 3? Okay, so how much water is in, what's going on at T equals 3? Well, it would be the water going in minus the water coming out. Oops, so that's going to be 3. Okay, so you don't have to take the derivative of this because the originals R of T and dt are the rates already, so that already is the derivative. Okay, so you're going to put this all into your calculator, and you're going to get negative 0.3136. And you're going to say it's decreasing because the derivative is negative. Okay, and the point values for that is this is equal to 1 point, and then this piece here, finding the actual answer and giving an explanation, is worth 1 point. Okay, we're up to part C. Okay, so let me erase this. Okay, halfway there. Okay, so now we're up to part C. So part C is saying, when is the water at a minimum? So that means we're looking for an absolute minimum. That's what this is about, this question. Okay, so an absolute min can occur, you wouldn't have to write this, I'm just writing this for you guys, can occur at a critical point or at an endpoint. You should be writing this down. Okay, so our endpoints are 0 and 8. So let's make a little chart. So we're going to find out what happens at 0, what happens at 8, and then we're going to see if there's any critical points. Okay, so let me erase this. So let's do 0 and 8 first, and then we're going to look for critical points, okay? All right, so what happened at 0? Well, at 0, there's 30 feet of water, because they gave it, that was in the given. It said there are 30 cubic feet of water in the pipe at time T equals 0, so that was easy. Okay, then we have to figure out what's happening at T equals 8. So for T equals 8, it would be everything that happened up until 8. That's what you're going to have at T equals 8. So you're going to have the 30 plus the integral going from 0 to 8, and it's going to be R of T minus the water that comes out. Okay, so you're going to put that all into your calculator, and at T equals 8, you're going to have 48. I'm going to just make a little more room so I could give you the actual value. So at 0, it was 30. At T equals 8, you should get 48.5436. Okay, and now you have one more to do, and that's to check for critical points. So how do you get a critical points? You take the derivative and you set it equal to 0. But you were already given the derivatives, so we're going to do 30 plus the integral from 0 to 8 of R of T dt minus the integral from 0 to 8 of the water coming out, and you're going to set it equal to 0. Okay, so you're going to solve all that, and when you do, you're going to get that T equals 3.2716. That means that's the critical point. Okay, so let's see how much water there was at the critical point. So 3.2716. Okay, so you're going to pop that into 30 plus the integral from 0 to that minus the integral from 0 to that, the 3.2. You're going to get 27.9645. Okay, so you're looking for the absolute minimum, so you're looking at the y values. Okay, so that's this group. Get a different color. That's this group over here. So which is the smallest number? It looks like this is the winner. So you're going to say, so the question is saying at what time is the minimum? So you're going to say at t equals 3.2716, the water is at a minimum. And then you could just put in parentheses 27.9645. This is it liters? Feet cubed, because it's volume if you're filling it with water. Okay, and we have one more, which is part D. So that one is a little bit time consuming, so if you're running low on time, that's going to be one you're going to choose to not do. Okay, and then for part D, it's saying that the water can hold 50 feet before it's going to overflow. Okay, so it's got to be, if it goes more than 50 feet, it's going to start overflowing. So the question is to write an equation, so it's going to be an integral, but you don't even have to solve it, they just want you to write it, to show when the pipe will begin to overflow. Okay, so how much water is ever inside this pipe? It's going to be the original 30 you're starting with, going from 0 to W, because it said time W, of R of t minus d of t dt. And if, let's see, write the time when it's going to begin to overflow. So once it gets to 50, that's when you're going to have a problem. So when does it equal 50? Really, you could also put, or when it's greater than 50. Either one of those really should suffice. And I think I forgot to give you some point values. And you don't have to solve that, by the way. So for number 3, I forgot to give you the point values. So if you just did, for this is number 3 I'm talking about, if you just did R of t minus d of t equals 0, if you set that equal to 0, you got 1 point. Your answer was 1 point, and then your justification, which would have been showing the 3 points, that would have given you another point. And for this part, part D, the integral got you 1 point, and then adding this part got you another point. And that's it, we're done.